That's not good for you.
That's not good for you. I read
No.
that it was good for you.
No, because you never really reach a REM sleep if you do that.
Supposed to sleep longer and different
Okay, so today we are starting complex numbers. This is very similar to the whole complex solutions thing that we did before, except there's no quadratic formula involved and no square roots for the most part. Okay, so that is the ultimate question. A complex number is a number that is composed of an imaginary part and a real part.
So there's a
So if I have the number a plus bi, a is the real part, so that's a whole number that we acknowledge exists in our real number system. And then we have our imaginary part, which has the I on it.
So an I means that's like the imaginary part.
Yes, I indicates imaginary. A real and an imaginary together create a complex number. So what we're doing today is we are combining complex numbers to simplify them, and then we are rationalizing a denominator that has an I in it. So it's important to note just a couple of things. The first one is we know that I is equal to the square root of -1, correct? We did this whole thing before. That's why we're able to pull it out of a negative value under a square root and make that value positive. This means that if I end up with an I squared, this is equal to the square root of -1 squared, which equals what? It'd be -1. Because we're not multiplying the negative ones together, we're multiplying the square roots together. So a square and a square root cancel each other out, leaving just the value underneath. So the most complex thing about today is that if we end up with an I squared, we can reduce it with a -1 and simplify. So you'll understand what I mean in a couple of minutes when we get there. We're going to start with the combining like terms portion first. So the first example I would like to do is 10 plus 25i plus 11 minus 3i. Oh, we'll do minus. Yeah. 20 minus 7i. So I have three complex numbers that I would like to put together. When we put this together, we combine terms that contain the same or that are the same part of the complex number. So I'm going to put all of my real parts together. So I'm going to end up with 10 plus 11 minus 20. What's 10 plus 11 minus 20? 1. So my answer in the real part is going to have a 1. Then I do the same thing with my imaginaries. I have 25i minus 3i minus 7i. If you need to write that out, that's 25i minus 3i minus 7i. When we combine this, we just put the whole numbers together and our answer will have an I on it. So what's 25 minus 3 minus 7?
Or 15.
Positive 15 and then I. So my complex number answer is 1 plus 15i. That's it. That's all we did on this part.
That's all you need to figure out.
Yeah, I was just simplifying by combining like terms.
Oh, can we just keep it?
Yeah, please. I am going to make this a 2-day lesson just to make sure we understand it. So we'll see how far we get today. Huh?
Yeah, why did you say this?
Well, there's more to a lesson than just what we do initially. Always.
Yeah, than just the easy stuff.
I totally forgot to take attendance.
First out of how many parts? 2, 3, 26?
We'll say 3-ish. 3-ish. Parts. Give me a second to take attendance really quick. There's like nobody here. Okay, So I would like to do another example, of course, because, well, it never hurts to have the practice. So on this example, I'm going to have 12 plus 3 minus 4i plus 2 minus I minus 3i. When we simplify this, we focus on one part of a complex number at a time. So I always start with the real part. What are my real parts in this problem? 12, 3, and 2. So I have 12 plus 3 plus 2 equals what? Then I do my imaginary parts, which is negative 4i, negative I, and negative 3i. So I have negative 4 plus negative 1 plus negative 3, which is negative 8i. And then we're done. We're going to get in a second. How do we feel about that?
This part's easy.
Anything super crazy? You have a question, Camden? Okay, just checking. So now let's multiply some of these together. So let's say that I have, for example, 15i times 5i. When I multiply something like this together, I multiply the numbers and then I multiply the i's. So what's 15 times 5?
35.
What's I times I?
I squared.
But we know that I squared is an actual number, right? What does I squared equal?
-1.
So this is the same as 75 times a negative 1, which makes it a negative 75. Kind of. How do we feel about that one? Not too bad? Do we want to do another one? Yeah.
If it's just this,
Does it get any harder?
if it gets harder than this, then yeah, like if there's gonna be like, say, if like some changes, do you know what I mean by some changes?
Yeah, I do.
Yeah. Like, there's only gonna be one eye there, and I'm just gonna have to know what to do.
Oh.
Yep, see, right there.
Yeah, that was
Okay, so it looks harder than it actually is. When I have no addition or subtraction inside of the parentheses and I'm taking it to a power, I can just apply the exponent to each part of my parentheses. So then this is the same as 2 cubed times I cubed. So we deal with the whole number first. What's 2 times 2 times 2? 8. It's the I cubed that's kind of throwing me because I don't know what to do with an I cubed. So let's separate it into an I and an I squared. So then this is the same as 8 times I squared times I. And I know what I squared is, correct? Negative 1. So then this is the same as 8 times a negative 1 times I, which makes it negative 8i. It is annoying to remember. I do get that. How do we feel about that one? Decent? Anybody super duper confused? Because if you are, please tell me. We're good? This part right here? Or this part? Okay, so I knew the 2 cubed turned it into 8, right? I've never approached an I cubed before, so I wanted to break it down into stuff that I could deal with. So I to the third power is the same as I squared times I to the 1, because 2 plus 1 makes 3. I know that I squared is equal to negative 1, and then the I is just I. So then I have I, or 8 times negative 1, because that's what the I squared was, times I, which makes negative 8i. That make sense? Okay. Anybody confused?
So to simplify it, it's pretty much just whatever the number itself is, it's just negative that I.
Yeah.
So it's cubed.
Okay, so let's do another one. Let's do 2i times 3 minus 6i. So this one's a little bit different because I have subtraction happening in that second parentheses, which just means I'm going to take this 2i and distribute it to both of those terms. So I'm going to do 2i times 3 first. 2 times 3 makes 6, and then the I stays with it. And then I have 2 times a negative 6 makes negative 12, and I times I makes I squared. We're going to pause here so everybody can see what we did. I am not simplified until there's just an I. So there can never be an I squared or an I cubed or an I to the 4th in here. That is not simplified because I can always break that down farther. Which means I need to do something with this I squared that's right here.
Why is there so much I on the first part? I thought it.
Because 2i times 3.
I know, but I thought you had to do your formulas first.
We did. So I did 2 times 3 is 6, but I had an I attached to this 2. So it has to travel with it as well. What do I know that I squared is equal to? So then I just replace it with negative 1, and I get 6i minus 12 times a negative 1. I do negative 12 times a negative 1 to get a positive 12. And then I always move the whole number to the front. So when I rewrite it, my imaginary term is always last. So I end up with 12 plus 6i. Give you guys a second to really process that one. How are we doing with that? Anybody super confused? Okay, so let's do another one. So now I have 6i times 3i times 2i minus 1. What is the first thing we don't like about this problem? There's 3 factors, which means I'm just going to deal with 2 at a time. I always like to work from the left to the right. So I'm just going to multiply 6i and 3i first. So 6 times 3 is 18. I times I is I squared. I can simplify that, however, because I squared equals what? So then I take 18 times negative 1, and I get negative 18. And then I'm going to multiply that into my third parentheses. Negative 18 times 2i is negative 36i. Negative 18 times a negative 1 is a positive 18. And then I reorder it, so the imaginary term is last. So this is the same as 18 minus 36i. Give everybody a chance to write that. Ready for the next one? Now I have 8 plus 4i times 5 minus 3i. I notice here, that I have a binomial times a binomial, which means I'm going to have to do what to multiply this out? FOIL. Okay?
That was what again?
First, outside, inside, last.
Oh.
So I'm going to color code this so that we have the practice. Sorry. So we do our first terms first. So I do the 8 times the 5, which gives me 40. Then I do my 2 outside terms, which is going to be 8 and negative 3i. 8 times a negative 3 is negative 24, and we just keep the I with that. Then I do my inside terms. So 4i times 5. 4 times 5 is a positive 20, and then we tack the I on. And then I do last. 4i times a negative 3i.
Negative 12i.
Negative 12i squared. Because I had an I times an I on there. And then I combine like terms and continue to simplify. So obviously I can put these two together because they both have just one I on them. So what's negative 24 plus 20?
Negative 4.
So this becomes 40 minus 4i minus 12i squared. So I have combined like terms. Am I done simplifying? No, because I still have an I squared, but I know what I squared equals.
Negative 1.
So then I take negative 1 times negative 12, which makes it positive 12, which I'm then going to add to the 40 out front. So then I get 52 minus 4i. I heard that, Hannah.
I don't know if she heard of it.
Yeah, I didn't.
I have like that hearing. You'd be surprised the stuff I hear in this room. I just ignore most of it.
I think selective hearing is like a thing that humans really have.
Oh, it is. And they actually prove that certain voices you just naturally tune out without even thinking about it, so you never pay attention to what they say. Hopefully my voice is not one of those, but you never know.
I was gonna say, because I had no idea what Hannah said, but like, say Grant said something, I feel like I'd hear that.
It's also the decibels, so the pitch of her voice might just not sync with you, whereas I'm a female, so the pitch of her voice probably just makes it easier for me to hear it.
I didn't even see girl power.
I don't know. There are a million different factors. Okay. Is anybody confused by how we got the 52 minus 4i? So we are going to do another one as practice, and then I think I'm going to stop for today. Because I don't want to overwhelm you. There's not a whole lot left, but I don't want to fry your brains on a Friday.
You're the only teacher that thinks about that.
Because
I've had every single math teacher.
You have, haven't you?
Yeah. I had a couple and I've heard she's the only person that cares.
Okay.
Honestly, as a person who used to have prompted, I can agree with that.
So I have the quantity 3 plus 2i all squared. Hold on. I want everybody to think about what this means.
It's just that times 2, so you can just add another one.
Okay, so it is not the same as just squaring each term inside of it. Because there's addition, it works a little bit differently. So what Cole is saying is that since this is a squared, this means this parentheses is repeated twice. So this is the same as 3 plus 2i times 3 plus 2i. And then it's going to work just like the previous problem where I FOIL it out. I'm going to color code it again for you so you can see how it works. And then we'll simplify it and be done. So let's start with pink. I like pink. When I FOIL, I follow the acronym. So first, outside, inside, last. My first 2 terms are 3 times 3, which is what? 9. Then I do my outside terms, which is the first term and the last term. So I have 3 times 2i. 3 times 2 is 6. I just tack the I onto it. Then I do my inside terms. 2i times 3 is 6i again. And then I do my last, which Hannah is what? Perfect. Now I have 9 plus 6i plus 6i plus 4i squared. Camden, what's my next step? I combine like terms, which means that the I attached has to have the same exponent. Both of these have no exponent, which means it's a 1. So I can put them together. So 6 and 6 becomes 12. And then I still have the plus 4i squared at the end. Am I finished? No, because I still have an I squared, which I can't allow because I have a value for I squared. What is I squared equal to?
-1.
So then this positive 4 becomes a negative 4 and combines with the first term. So I have 9 plus negative 4 is a positive 5 plus 12i. And then we're done. How do we feel about that?
Pretty good.
Okay, your homework is on Canvas. It is due Tuesday because we're going to do the second half of this lesson on Monday. As always, if you have questions, let me know. I do hope that you're going to take the time we have right now because we still have about half an hour to work on it.
Oh, wait, hold on. I just